All right, now that we have the automata assembled, okay, and it's functioning and I can move it, and of course it snaps back to the origin there. What we're going to be doing for the rest of the cams in motion is generating a angle displacement graph. So for this is the eccentric cam that everybody's going to do, and then you're going to choose one of the other three cams to go through this activity and try to get it to animate as well as do the angle displacement graph for the other cam. Okay, so you'll go 0 to 360 counting by 45 degrees for your angles. If you happen to select the hex cam, then you'll need to go every 30 degrees. We'll give you a little bit better sketch of the graph. All right, so in order to do that, first of all, make sure that your cam is set on 0 degrees for that revolute constraint. So make sure that very first revolute joint we put on is 0 degrees, and then using the inspect tool, we can measure from the top of the follower to the top of the box. So I'm getting 2.188 inches. Okay, so you'll want to write that down and make that chart first of all in your engineer's notebook, so then you can put it in Google Sheets. After you get that measurement, then we can modify that angle to be 45 degrees. And now we notice that the follower moves. So then we can again measure from the top of the follower to the top of the box. 2.285 inches and so on. So when you're done with all those measurements, you should have very similar measurements to what I have here. Unless you had a slight mistake on your assembly, or you made something a different length, or you have a different size cam or follower, then those numbers might be different, but the eccentric cam should give us this overall shape. Although if you started with your cam at the highest location, then that graph might be flipped, where it would be start at the maximum displacement and go towards the minimum displacement at 180 degrees. Okay, so after you complete that with the eccentric cam, then you're going to select one of the other three cams and try to do the assembly and do the same thing with the assembly, the slider joint. Again, the hardest part being trying to figure out what that offset needs to be so that the follower or the roller rides right directly on the cam. That value must be exact and not just close. It must be an exact value. The other thing when you go through that, what you'll need to do to play with it so it doesn't have to sit there, you have to turn off the contact set in order to do your additional cams. So when you're all said and done, you should have two different graphs of the displacement and the motion created with the follower from the top of the box. Okay, so that finishes up our cams in motion.